The Hubble Space Telescope is many things. It's an observatory, a satellite, and an icon of cultural and scientific significance. But you might be surprised to find out that Hubble is also a time machine. No, not like that. With Hubble's position just above Earth's murky atmosphere, its clear view literally lets us witness our universe's past. It allows us to travel back in time and see things as they were 1.3 seconds ago, 33 minutes ago, an hour ago, or even a little bit older than that. But how does that work? After all, Hubble doesn't travel beyond our solar system, or even our home planet's gravity. So how can it see the past? The answer is light. The term light year shows up a lot in astronomy. This is a measure of distance that means exactly what it says. The distance that light travels in 1 year. Given that the speed of light is 186,000 miles per second, light can cover some serious ground over the course of 365 days. Almost 6 trillion miles worth. Hubble works by gathering light from objects in our universe. Some as close as our moon or comets coming into the inner solar system, and some as distant as galaxy clusters that are billions of light years away. All that light takes time to reach the telescope, just as it takes time for light to travel from its source to our eyes. For example, our sun is located about 93 million miles from Earth. That means that it takes roughly 8 minutes for its light to reach us here on our planet. So when we look at the sun, we see it exactly as it was 8 minutes in the past. Cosmically speaking, the 93 million miles between us and the sun are nothing. We orbit around just one of billions of stars in the Milky Way galaxy, which is one of countless trillions of galaxies in the universe. With that in mind, time travel gets more intense when Hubble observes objects beyond our star system. Think about what you were doing 4 years ago today. What type of sandwich you were eating. What song you were listening to. What work or school assignment you had. Or the car you drove. Keep those images in your head as you now think about the next closest star to us, named Proxima Centauri. It's about 4 light years away, which makes it a close neighbor on a universal scale. So right when you ate that ham, tuna, and peanut butter sandwich 4 years ago, the light from Proxima Centauri just left the surface of that star and began zooming out towards us. And here we are, 4 years and many sandwiches later, and that light has finally arrived. Now think about what you were up to 700 years ago. Or at least imagine what your great, add 30 more greats and you'll get the point, great-great-great-grandparents were doing in the 1300s. If they were in Europe, they might have been a brave knight fighting for their king and country and money. If they were in Japan, they might have been an early samurai helping to overthrow the Kamakura shogunate. If they lived in Africa, they might have been collecting gold from Mansa Musa. Or maybe your ancestor even was Mansa Musa, arguably the richest human of all time. During all of those events, the light from the giant star Betelgeuse left its surface. And all that time, from the 1300s up until today, that light was traveling at 186,000 miles per second towards us. This means that when Hubble looks at Betelgeuse, the star appears exactly as it was 700 years ago. Want to go even further back in time? Well, our next stop is the Andromeda Galaxy. The Andromeda Galaxy is a whopping 2.5 million light years away. But that's just the closest major galaxy to us here in the Milky Way. Things were so much simpler back during the Paleolithic period, weren't they? Dinosaurs had only been extinct for 62.5 million years as opposed to 65 million years ago. Sandwiches weren't even invented yet, let alone peanut butter for sandwiches, let alone sliced bread for peanut butter sandwiches on sliced bread. And the very earliest humans were just figuring out how to be human. Smartphone technology was still quite a few years away, though. Perhaps some of Hubble's most legendary observations are its deep field images, which collect light from thousands of galaxies that are billions of light years away. With this type of imagery, we can better understand how our universe changes over time by puzzling out how galaxies evolve. The farther back we look with Hubble, the closer we get to the Big Bang, when the universe began. So the most distant galaxies observed by Hubble often appear to us as the youngest ones, giving us a sneak peek at the universe in its infancy. Because these galaxies emitted their light when they were young, we get to witness them in their early stages. These young galaxies are actually old galaxies now, as they have evolved over the time the light has taken to reach us. Hubble has observed galaxies as far back as 13.4 billion years in the past. That's just 400 million years away from the Big Bang itself. So hopefully you've enjoyed this time-traveling trip with the Hubble Space Telescope. But remember, you can time travel all on your own without a fancy space telescope as well. The next time you're outside at night, remember to look up at the stars. You're seeing those stars as they were hundreds, if not thousands of years ago. Those photons of light have been traveling very far and very fast over a very long period of time to reach your eyes at that one special moment. So don't blink, or you'll miss it.